It is said that Jupiter is a failed star. Had it succeeded, how different would our solar system be? And would life evolve on Earth? Would Earth be in overlapping Goldilocks zones of the Sun and Jupiter? What's a Goldilocks zone, first of all? A Goldilocks zone is a certain distance away from your star where water can exist in liquid form. So in the solar system that we inhabit, the Goldilocks zone ranges. So the planets Earth and Venus are in the Goldilocks zone. So Earth and Venus have temperatures where liquid water can exist. Mars is slightly just way beyond the Goldilocks zone. Uh, in the past, I think liquid water did exist in Mars. So you could say Mars is also in the Goldilocks zone, kind of. But it's much colder. It's further away from the sun. So the Goldilocks zone is that region away from a star in orbit around the star, any star, where liquid water can exist. That's Goldilocks zone. Now, is Jupiter a failed star? I wouldn't say Jupiter is a failed star. What is a failed star? You generally refer to brown dwarfs as failed stars. So, what does it mean for a star to fail? For a star to fail, it means that it doesn't have sufficient mass to ignite nuclear fusion reactions, sustainable nuclear fusion reactions in its core. So if you look at the sun, our sun, it's this bright ball of light, right? Extremely bright. We are so far away from it, and yet it heats up the surface of the planet and causes all the weather and all that. And at the heart of the sun, there is this gigantic, massive nuclear fusion reaction. If you want to see what a nuclear fusion, what a hydrogen bomb looks like, look at the sun. That's an ongoing fusion reaction. So why is the sun able to sustain fusion? It's because it is massive enough to such that the pressure and temperature at its core is enough to have a sustained ongoing fusion reaction that's been going on for 4.5 billion years, 4.5+ billion years. So that's a successful star. It's able to sustain fusion, right? It's able to ignite, first of all, a nuclear fusion reaction, and it's able to sustain that because of the amount of mass it has, hydrogen mainly, a little bit of helium. Now, a failed star is a star which is a blob of gas, essentially, hydrogen gas, which doesn't have enough mass to ignite or to sustain nuclear fusion. So, the smallest mass that you need to ignite deuterium fusion, which is deuterium is a special form of hydrogen. Okay, hydrogen, what is hydrogen? It's an atom, right? It's a gas. The gas has atoms, and that the hydrogen atom is just a proton in the nucleus, then you have an electron going around it. You can look at it like that. Okay, it's not exactly like that, but yeah. So a hydrogen atom has a proton and an electron going around it. In deuterium, you have a proton plus a neutron at the in the nucleus, and you have one electron around it. So it's slightly different. It's a special kind of hydrogen. And there's tritium as well, which has two neutrons. So if you have an object, a gas giant, which has roughly 13 times the mass of Jupiter, then it has enough mass to ignite deuterium fusion reaction. And that's kind of it's a reasonably cooled object. About 2000 Kelvin is the surface temperature of a brown dwarf. So it's kind of there is a fusion reaction going on in there, but it's not really hydrogen fusion. It's deuterium fusion. It's much cooler, and such objects are not very luminous. That's why they're called brown dwarfs. So the minimum mass for deuterium fusion is 13 times the mass of Jupiter, and the minimum mass for proper hydrogen fusion is about 75 to 80 times the mass of Jupiter. That is the lowest mass limit at which a red dwarf can exist. So such stars are called red dwarfs, and red dwarfs are much cooler than the sun because they are. You can see that they are red, like the light behind me, and they are very long-lived stars. Their lifetime is typically of the order of trillions of years, so they will outlast. Well, the way they will, the universe is 13.8 billion years old. So red dwarfs will essentially live forever. From if you look at the current scale, the current age of the universe. So that's what it is. Okay. So with that understood, Jupiter has is way too small for to even ignite deuterium fusion. So Jupiter isn't a failed star. Jupiter is just a gas giant planet, the largest planet in our solar system. It simply doesn't have enough mass to ignite or sustain, to first ignite and then sustain any kind of nuclear fusion reaction, even deuterium fusion that you see in brown dwarfs. So it's not a failed star, but let's say you have a star, a small star where Jupiter is currently. Okay, let's say you have a star. The smallest star you can imagine is a brown dwarf, which is 13 times the size of Jupiter, the mass of Jupiter. Well, what would happen then? Well, that star would be way too far away from us. So the dynamics of the solar system would be affected somewhat because of the larger mass of this object, which would cause, if you were to suddenly like do a thought experiment and and replace Jupiter with a brown dwarf, what could happen? It would perturb the orbits of the various planets. It could cause certain planets to move, the orbits of certain planets to move, possibly. Some, planets could, over a long period of time, perhaps be thrown into different orbits, or maybe even ejected, possibly, depending on the mass of this object, of this brown dwarf, in orbit where Jupiter currently is. It would change overall the dynamics of the solar system, the orbital dynamics, and so on. Uh, what else would it do? It would not be warm enough to make much of a difference when it comes to the Goldilocks zone that Earth resides in. So Earth would not. Maybe it would certainly be visible, more visible than what Jupiter is. You can see Jupiter with the naked eye, but if you want to, but it's not that luminous because it is simply light that's reflected off Jupiter, sunlight that's reflected off Jupiter. But in the case of this hypothetical brown dwarf, it would have its own light, which would be more luminous than Jupiter, possibly, but it would not give us enough warmth that it would make much of a difference to us. What if you had a red dwarf there? Then it would possibly make a significantly larger difference to the solar system because of the much larger mass, and it would be much more luminous than a brown dwarf. But still, it may not really change much when it comes to the Goldilocks zone, because a red dwarf is way cooler than the sun, and it will be quite a distance away. So overall, that's what could happen. Life would not really evolve differently on Earth. Obviously, the night sky would look different. You would have a bright object that isn't there right now. So yeah, it could change uh, the nocturnal cycles of animals, of birds, of insects, and all that. The circadian rhythms could change, perhaps that could be affected. uh, and yeah, the night won't be as bright, as dark as it is right now. So that is overall what could happen. I think there's this science fiction novel that I read a long time ago. I think, what was it, 2010 Odyssey 2 by Arthur C Clarke, one of the pioneers of science fiction and physics. And yeah, I think this concept is examined over there. There's an alien civilization that ignites Jupiter somehow and sustains fusion there, and it kind of changes. I think that new star is called Lucifer in that science fiction novel. So yeah, interesting thought experiment. That's overall the scenario.